In this problem, we're to find V0 using mesh analysis. We'll use our problem-solving strategy on loop analysis. Remember, mesh analysis is one of the ways to assign currents for loop analysis. So we have three meshes. So let's assign mesh currents. So we have three mesh currents. I1, I2, and I3. So we're going to need three equations. And note that we have a dependent current source this time. And anytime we have a current source, when we're doing mesh analysis, we're going to have a constraint equation. So let's write our constraint equation first. And the constraint equation would be I1 minus I2 equal to the 0.5 Ix. Now if we look at our circuit here in our assigned mesh currents, Ix is equal to the negative of I3. So then we have 0.5 times minus I3. So then we'd have I1 minus I2 plus 0.5 I3 equal to 0. There's our first equation. Now, we need two more equations. We know we do not apply KVL to any loop or mesh that contains a current source. We do have a mesh in the bottom right here that we can apply KVL to. So here's our circuit again. Let's label our mesh currents. Again, and what we're going to do is we're going to do KVL to mesh 3. So we'll have 6KI3, drop here, minus 8 as we come around. Then we'll have a drop of 3K times I3 minus I1. One more drop of 6K times I3 minus I2 equal to 0. So if we collect up terms, we'll have minus 3KI1 minus 6KI2 plus 15KI3 equal to 8. Here's our second equation. We need one more equation. We don't apply KVL to any mesh that contains a current source. But for instance, we could open up this current source and find some loop. And one loop is around the outside. So if we apply KVL to the outside, we would have a drop here, 2KI1 plus 3KI1 plus 4KI2 minus 12 plus 6KI3 minus 10 equal to 0. And if we collect up terms, then that equation becomes 5KI1 plus 4KI2 plus 6KI3 equal to 22. There's our third equation. Now we're ready to solve using MATLAB. So if we look at the data we would enter into MATLAB, here's our matrix that we would enter. Now if we entered into MATLAB, enter the equations in there, solve, we'll get I1 is 1.11 milliamps, I2 is 1.861 milliamps, I3 is equal to 1.5 milliamps. If we look back at our circuit, we'll certainly see V0 is 6K I3. So then V0 is 6K times I3, 6K times 1.5 milliamps is 9 volts.